Good morning, my name is Noel Castillo and I'm a full stack developer working at TMAAP. This past week I was working on a program that acts as a staff scheduler. It allows the user to create a weekly schedule in which they can create positions um, per day and per start or end time, and assign employees to those positions. So starting off, let's take a look at the database, PostgreSQL. So you're going to have two databases, one for your production and another one for testing purposes. The schemas will be identical, but the tests will have different testing rows that are just not used for we actually launch in production. So our actual database is called Staffer, and we call the other one Test Staffer. So looking into our production database, we have four tables. We have one for day, employee, position, and position day. Looking into the days table, it has two variables, an ID and a name of the day in the string. So you can pretty much store the 7 days of the week, Monday through Sunday. We have the under the employee table, we have three variables, an ID, first name and last name for the employee. For the positions table, we have a few more. There's going to be the ID, the title for the position, an employee ID. This employee ID is going to act as a foreign key. So one position or many positions can be assigned to one employee, but a position can only be filled by one employee. So that's how this foreign key is acting. And it doesn't have to be filled off the bat, so the user can create the positions first and then fill them later. Same with the start and end times. So these start and end times are going to be stored as strings initially and then parsed into actual time. And then we have a bridge table called position day. So the bridge table is going to act as a many-to-many between position and day. So a position can take up multiple days, and throughout multiple days you can have, or throughout one day you can have multiple positions. So that's going to be many-to-many. So moving on, let's take a look at the Java backend. So here I'm using IntelliJ for the backend. So starting off, you're gonna want controllers.
All right.
This is gonna
Yep.
be used to
Feel
map
free to
your
take a break when we come back in.
this is gonna be used to map your URLs to your desired methods. So for example, we have a get employee by ID. The URL is gonna be employee and a variable ID that's gonna be user inputted. So we have these URLs for like everything we want to accomplish. Getting employees by ID, by their last name, a list of all employees, adding an employee to the database, editing an existing employee, deleting an employee. Same thing for positions. And ultimately, you want to be able to do this for all of your tables in the database. For now, we got two employee and positions. We have a package for our exceptions. Throughout the running their program, we're going to run into improper input. It can be like invalid like names. It could be like empty strings, or it could be null inputs. So we have exceptions to catch those. And we have our models, employee and position. So they're going to represent our employee and position tables from the database. And then our mappers, these also represent our tables in database. It lets the Java side know how the columns are broken down in the PostgreSQL database. And then we have our interfaces for the DAO. It's pretty much a list of all the methods that we want to do um, for the for for the Java side to talk to the database side. And then the PostgreSQL. This is the actual like implementation of the SQL statements. So here you can see some examples. If we want to add our employee, we have a SQL statement. We're going to import a JDBC template, and this template can do quite a few things. It can do queries, it can do executes, depending on what method you want to accomplish. A query is going to return a list of something. In this case, it's going to return a list of employees, and when we add an employee, we just want the first one from that list. So get 0. Um, Something a little different would be getting employees by ID. Same thing. You just want to get the one. So you're gonna do employees like get 0, return the one. If you're getting a list of like say by employees by last name, in that case you can just return the entire list that you're querying for. Other methods such as editing an employee or deleting an employee, uh, for the purposes of like how I wanted to make these methods work, I just wanted to execute these. I didn't want to get anything back from the template executing the statements. I am returning true or false whether it was able to get in here. Um, so that's an example of some of these SQL statements. And then you have the service layer as well. So this is the controller links first to the service layer, and then the service layer calls the DAO. So looking at the first one, let's take a look at get mapping, get employee by ID. This calls an employee service, and the service layer has the same method, get employee by ID. We can go to the employee service class file here. You can see that the service layer imports a DAO DAO variable, employee Postgres DAO, and this is what calls. Let's look at the get employee by ID. You can see right here, it calls the same method, get employee by ID. It does some things if it's null, otherwise it'll return it. And looking at back at the Postgres DAO, you can see that it's here where it actually reaches into the database and brings it back to the service layer, and then from the service layer to the controller, and then from there it'll be outputted to the front end. And of course we have tests for everything as well. We have tests for all of the methods. You want to comment all your tests to kind of give a explanation of what each one does. And that's all that makes up the backend for this project. I hope you guys learned something from this. Thank you for watching.